We're going to do law of signs, the ambiguous case today. So, like, I don't know, maybe 5 years ago on the internet, this picture was blowing up because some people saw this picture and saw a white and gold dress like I do. And some people saw this picture and see a blue and black dress. Do any of y'all see the blue and black dress? It tends to be younger people that see the blue and black dress. What do you guys see when you look at that picture? White and gold, blue and black? Okay, so see, we have a mix. Jada sees the blue and black. Nicholas sees the blue and black. Right. I see the white and gold. So does Omar. I'm not alone here. So does Emily. Okay. And so that's what's really funny is if I'm looking at that dress, I only see white and gold. But some people see it as blue and black. And the people who see it as blue and black feel the same way that is a blue and black dress. So that's why I picked this picture as our ambiguous case. Okay, what is the dress? It's a bit ambiguous. We're not sure. And that's where it draws to light that our senses can't always be trusted. So my first degree is in psychology, and sometimes when it's not math time, I could talk to you a lot about sensation perception. There's some really cool things that happen between our mind and the real world. Okay, so we're reintroducing the law of signs. We're going to be using law of signs today, and hopefully after a little independent practice, you're really loving law of signs. It's pretty easy to set up, pretty easy to solve. Okay, we really like it. But today, we're going to be using it to solve for angles. You'll notice yesterday we were always solving for a side, and there was never a problem when we were solving for a side. But when we're solving for an angle, it's going to become a bit ambiguous, okay? So we can use the law of signs given two angles and a side. And it doesn't even matter which two angles you're given, if it's an angle-side triangle or if it's an angle-side-angle triangle. Because even if we're not given the angle opposite the side we have, if we're given two angles, we can subtract from 180 to get the third side, and then we'll definitely have an angle in the side opposite of it to get started. Okay, that's what we have to get started on a law of signs. We have to have an angle on the side opposite of it, and then one other piece of information, either a side or an angle to solve for. Okay, so but what if they gave us two sides and an opposite angle? Like, let's look at this information here. So that's going to be triangle ABC. So A would be 40, side A would be 3, and side B would be 2. Okay, I want you to think way back to your geometry days. I know it's been a while, but can you remember how you could prove triangles congruent? Okay, how much information did you have to prove that triangles were congruent? There were lots of different ways that you could prove triangles congruent. You could do angle, side, angle. You could do angle, angle, side, like we were talking about earlier. You could do side, angle, side. You could do lots of different combinations of angles and sides, 3 letters. There were only 2 that you could not do. You could not do angle, angle, angle. Angle, angle, angle only proves that the triangles are similar. They're the same shape, but not necessarily the same size. And what was the other one you couldn't do? I teach geometry. I say no bad words, right? So we couldn't do side, side, angle, which is a bad word backwards. We said we couldn't do those when we were trying to prove triangles congruent because that's not enough information to lock in one triangle. Now look at our triangle that we have over here. We have a side. Oh, let me do a color. We have a side, the very next side, and the very next angle. That is a side-side angle triangle. And that is not enough information to lock in one triangle. There could be 2 different triangles that have that information, okay? So remember that. When all you have is a side, the next side, and the next angle, side, side, angle in that order, that's not enough information to prove triangles congruent, so there may be a different triangle out there, okay? That's why it's the ambiguous case. It's just not enough information. That's what makes it ambiguous. Okay, so what are we gonna do about this? Okay, so in the video notes, Mr. B did a good job going through all the different triangles here and how we can tell what's going on and what's really going on. Now, spoiler alert, I'm not going to make you find the height and do all these comparisons, but I still want to talk about these pictures so that you could see what could be going on here. Okay, so let's talk about our options and what could be going on here. Okay, so when you look at these pictures, what I want you to see is that the angle is locked. Okay, so the angle Remember, an angle can have a ray. Right now it's just drawn as a ray, like we don't know how long that other side is going to be. But what we do know is we know this side length, we know this side length. So that's our side, our other side, and our angle. Okay, so that's what's locked in, our side, and angle. We don't know how long this bluish side is going to be yet. So right now it's just drawn as a ray where it could be any length, okay? But we're going to try to figure out what's going on there to find it. So we don't know how long that is, but we do know that side, and that angle when that's fixed in. Okay, so here's all the different possibilities that could be going on in this picture. Okay. So we're going to run through it with the opposite and height comparisons to talk about it, and then we're just going to do lots of talking here at the beginning. I don't want you to stress. All this conversation we're going to have on the next couple slides is to try to build your understanding. It's not going to be stuff I'm going to quiz you on, but it's for you to look at and be able to understand what we're talking about here. Okay, so the first option is that the opposite side here, so they labeled the side opposite the angle, they labeled that the opposite side. So O stands for opposite now, and we mean it's opposite the one angle that we have, okay? And then they labeled this side N, and in the way that Mr. B taught it in the video notes, that he wanted you to solve for the height, and down here at the bottom of the slide here, I have the formula for height. Okay, it says height equals N times sine A. Sorry, when I get my cursor close to it, it covers it up. So height equals N times sine A. They labeled this side that's adjacent to the angle that we know, they labeled it N. And we'll talk about why they labeled it N in a second. And then we have this angle that we know. Okay, so in the way that Mr. B taught in the video notes, he said we have to drop an altitude to find the height of the triangle, okay? And so that's what's drawn in here. It's not one of the sides of a triangle. This is a dashed line because it's an altitude or a height that they dropped, okay, to find the height. N is adjacent to the angle, okay? But let's talk about why they called it N and not H. Okay, so if you now look at this right triangle that we created by dropping an altitude, they didn't want to call this side NH for hypotenuse because we didn't want to confuse it with H, which is the height of the triangle. Okay, so they just needed a different letter for it. So they called it N there, okay? All right, so let's look at that first situation and what could be going on. If the opposite side is shorter than the height, okay, then that opposite side can't reach to touch to close the triangle. So there is no triangle at all there. Can you see that in the picture? It's not tall enough to reach the bottom because it's shorter than the height. Even if I swung it right next to the height, because we don't know this angle yet, this angle isn't fixed, even if I swung it right there, do you see how it couldn't reach the bottom? It couldn't make a triangle if it's shorter than the height, okay? So that's gonna create no triangle. So that's our first option. Okay, the second option is that the opposite side is equal to the height. So if the opposite side is equal to the height, it falls right on top of the height. They're equal to each other, and that forms one right triangle. So that does form a right triangle. Okay, so it would lock in, that would be our triangle then. Okay, so we've got two options so far, no triangle or one right triangle. Okay, now the next option is that ambiguous case that we were talking about, where there are two possible triangles, okay? So if the opposite side is greater than the height, okay, so here it was less than the height, and here it was equal to the height. If the opposite side is greater than the height, and that's what this says right here, that part of that inequality says that the opposite side is greater than the height, and it's less than this other side that we know. So it's less than the side N that we know, but it's greater than the height. There are two options we can have. You can swing that side in here, and the side angle opposite of N would be an obtuse angle greater than 90 degrees in there. Or it can swing out this direction, in which case that angle opposite N would end up being an acute angle. Okay, can you guys see those two options? The angle opposite N is either obtuse or it's acute. Okay, it's either greater than 90 or it's less than 90. We know it's not equal to 90. If it were equal to 90, we'd have just the one right triangle option here at the top. Okay, questions about that so far? Okay, and then the fourth option is that the opposite side is greater than the height, because remember, if it was less than the height, there's no triangle. If it was equal to the height, there's one right triangle. So if the opposite is greater than the height and it's greater than n, okay, now this long side is super long. It can't swing back this direction like it did in this picture, because even if we swung it all the way back, like if I swung it all the way back, it would still be longer than n. So it wouldn't make a triangle. Do you see that? It couldn't make a triangle because it's too long. Okay, so it does make a triangle when we swing it out in this direction, but there's only one triangle that's an option now. Now, one thing I want to point out, that says one oblique triangle, not obtuse triangle, okay? Now, whether or not it's obtuse is a secondary question, okay? But the point is, I saw that word oblique and I saw the OB and I just kind of in my head thought obtuse. I'm like, it's not obtuse. And so I wanted to point that out here. The angle opposite of n right now is an acute angle here. It's an acute angle that's opposite angle n. Okay, and the reason I point that out is because when we do our law of sine setup, we're going to have the sine of our angle that we know, which here is angle A, is to the side opposite of it, which they labeled angle O, okay, as the sine of something. I'm going to call it theta, is to the side they labeled n. We're going to be looking for that angle opposite n because that way we only have one variable in the equation. Here's when they're giving us this. They're giving us this side, and this angle. So we're plugging in our side angle and we're solving for an angle. And that angle is going to be the angle that's opposite n here in the picture, okay? So our options are that there's no triangle at all, that angle opposite of n is a right angle, or that there are two options where it's either acute or obtuse, and there's two different options, or it's just an acute angle, okay? Those are our 4 different things that can happen. Questions for me about that? I just think it's kind of nice to visually see why all these triangles are options and what can happen here. Okay. All right. So Ms. Weaver's been talking about it. So let's jump to our next slide. Still more talking to come. Still just trying to build intuition and understanding. Still feeling no pressure about this discussion because I'm not going to ask you to replicate this or to explain it to me again. We're just trying to make sure you understand it. Okay, or trying to increase your ability to kind of understand what's going on here. We learn with repetition and time, okay? So all year, we're going to continue to try to make connections back to other things that you know to try to strengthen and deepen your connection, okay? All right, so in that starting information that I gave you on that first slide where we first drew this triangle, okay, they gave us an angle and 2 sides. It ended up being a side-side angle. We said it was our ambiguous case. So here's our setup for a law of sines. The sine of 40 is to the side opposite of it, which is 3, as the sine of beta. And by the way, for Greek letters for angles, we usually use Greek letters for angles. So the one you're most used to seeing is theta. When we have an ABC triangle, we usually use across from angle A, we'll use the Greek letter alpha. Across from angle B, we'll use, not across from. For the angle A, we'll usually use alpha. For the angle B, we'll usually use beta. Okay, and for the angle C, we'll usually use gamma. And that's because those are the first 3 letters in the Greek alphabet. And if you haven't drawn them before, we can talk about how to draw them just real quickly as an aside. So alpha, beta, gamma are the first 3 letters in the Greek alphabet, just like ABC is in ours. The alpha you're probably used to making. You probably made that in geometry. It's our little fish-looking angle. Okay, you come down, loop around, and that makes alpha. The beta kind of looks like a capital B, kind of cursive, but you start with a longer tail and then loop up and make the rest of it. Okay, so longer tail and then loop up, and that's beta. Gamma is the one that's a little bit tricky, but it's really just like a skinny fish standing on its head, okay? Like a super skinny fish standing on its head is how I would describe how to draw it. So gamma, you come down and then loop back up. You come down and loop up, down and loop up, down and loop up, okay? And so that's gamma. All right. So I used beta because it was representing angle B here. All right. So when we go to do this, we're going to cross multiply in the direction that does not have the variable and divide by the other number, okay? So the sine of beta is going to be 2 sine 40. Let me write that. The sine of beta will equal 2 sine 40 divided by 3. Okay, but we don't want the sine of beta. We want beta itself. So how are we going to find beta? What finds angles? Inverse finds angles. Okay, inverse finds angles. So if you think of doing the sine inverse of both sides of the equation, okay, sine inverse of sine cancels each other out, and that just gives us beta equals sine inverse of 2 sine 40 divided by 3. Okay, so we're going to be doing inverse to find our angles, and this is where, if we'd gotten to teach things this year in the normal order that we teach them, you would have already seen the graphs of our trig functions, and we would have already restricted the domains of the trig functions to make them one-to-one so that we could find an inverse of them. If you remember back from your Algebra 2 days, or even your, I think you did it some in Algebra 1 as well, when you have to find an inverse, it's got to be a one-to-one function for the inverse to also be a function, okay? And so we have to restrict the domain of the original function to make it one-to-one, and then that creates because the domain of the original becomes the range of the inverse. It turns out that the range of sine inverse, okay, and we have a little way to write this to help us remember. We write it like this. The range of cosine inverse is quadrant 1 and quadrant 2. The range of sine inverse is quadrant 1 and quadrant, we call it quadrant -1, okay? Because it picks up the negative angles, like this would be negative 30 degrees or negative 45 degrees or negative 90 degrees, right? So we call it quadrant 1 and quadrant -1. But what's important to us for today's application, okay, are we going to want negative angles for triangles? Do we have any triangles have a negative angle in them? Not triangles that you just draw by themselves. We draw triangles when we're in negative angles, right? But if you have a triangle in the real world, none of them can have a negative angle. So we're not going to be interested in these negative angles here, okay? And so what becomes important is that sine inverse is only going to take us to quadrant 1. It's only going to give us answers for quadrant 1, okay? Well, what kind of angles are in quadrant 1? Just angles between 0 and 90, okay? So when we do sine inverse, it's only going to give us acute angles. It's only going to give us acute angles. And if we go back and look at our other slide of all the different options that could happen, 2 of those options had acute angles. Okay, and one of them had a 90-degree angle, which sine inverse can tell us that it's 90, okay? So that's a pretty good option to have, that the inverse is going to give us those options, but what it's not going to give us is this obtuse angle. It's not going to give us the angle that comes from quadrant 2. If you come back and look at our picture here, okay, it's only going to take us to quadrant 1. Sine inverse only goes to quadrant 1 and -1, and we're not interested in quadrant -1 today. So it's only going to give us quadrant 1 answers. So how are we going to find the obtuse angle? What are we going to do to find the obtuse angle? Okay, so let's take a look at a picture here. So if I draw in an angle in quadrant 1, so let's say I did my sine inverse and it gave me this angle. I'll go ahead and call it theta here. It gave me theta in quadrant 1, okay? Because let's say that theta had the sine inverse of 2 sine 40 over 3. Okay, what if this was supposed to be the option where there were 2 triangles? Now, I know that it's got to still have this as its sine. The sine of the angle still has to be the same setup. It's just that we're saying it's supposed to be an obtuse angles. So what angles have the same trig values? What angles would have the same sine value? Thanks, Lennon, for letting me know you're here. I'll change your attendance. I'll give you a second to pause and think about that question while I take attendance real quickly. Okay. So if it's got to have the same sine value, where would its triangle be? What would it have to look like? So think about that for just a sec. Okay, so we learned at the beginning of the year that angles with the same reference angle have the same trig value. Okay, so if I were to drop an altitude perpendicular to the x-axis here, okay, and use my x, y, and r values to get my trig values for my angle theta that sine inverse can give us, okay, then I could have another triangle here in quadrant 2 that was that same distance theta from the x-axis. And it would have the same trig values. The only difference is because of that negative, its cosine would be negative and its tangent would be negative, but it would have the same trig values. Do you remember us talking about that with the unit circle? Like all my 30-degree angles have the same trig value. And I call them 30-degree angles because they have that same reference angles of 30 degrees. Like if this was 30, if theta was 30, then this one would be 30 degrees away from 180. So this would be 150. So the angle 30 and the angle 150 have the same trig values. The only difference is the sign on the x. Okay, are you guys with me? Yes or no? Does that sound familiar? Thumbs up or thumbs down in the chat? Okay, kind of with me. Good, good, good. Okay, all right. So how could we find that angle if all I knew was the 30? Let's say that sine inverse gave me 30 and I just knew that. We want to remember that that's our reference angle. So how can we find the quadrant 2 angle, the obtuse angle that's supposed to be our second option? How can we use the angle that the calculator will give us to find that second angle? It's going to be 180 minus the reference angle. It's going to be 180 minus the reference angle. Remember, so our quadrant 2 option is going to be 180 minus the reference angle. Okay, so if it's a 30-degree reference angle, 180 minus 30 is 150. Okay, if it's a 42-degree reference angle, then 180 minus 42 is going to be, I should have given myself something easier. What is it, 138? Okay, so it's going to be 180 minus the reference angle. That's how we're going to find the quadrant 2 angle if there's 2 options for the triangle. Okay, so we're going to do 180 minus the reference angle. And that's kind of the big idea that I want you to remember. Sine inverse is only going to give us the acute angle in quadrant 1 if we're supposed to have an obtuse option as well. And remember, 3 of the 4 scenarios did not have an obtuse option. But if we are supposed to have an obtuse angle as well, the way we're going to find it is we're going to do 180 minus that reference angle that we got in quadrant 1. Remember, when you're in quadrant 1, the angle itself is the reference angle. The reference angle, the definition of a reference angle is the distance between the terminal side. Let me highlight this. The distance between the terminal side and the closest part of the x-axis. Okay, so the distance between the terminal side and the closest part of the x-axis is the reference angle. In quadrant 1, it's the angle itself. Okay, so a 150-degree angle has a 30-degree reference angle. And to use the reference angle to find that angle, we would do 180 minus 30, and that would give us the 150. Questions about that? And I'm going to show you that part over and over again. Okay, we're done with the deep mathematical thoughts from Ms. Weaver. I'm sure you did not absorb all of that first time through. I'll probably post a recording of today's class, so if you want to go back and re-listen to this part and try to do some deep thinking again, that you can, okay? And I'm happy to talk to you about it more too. Like if you later want to have a discussion during our flex time, I'm happy to talk to you more about it to try to help you understand better as well. Okay. So now we're ready to start actually solving some problems. So let's do this. Okay. Now, like I said, I'm not going to make you find the height. There's more than one way to work a problem. So the way that Mr. B does it, he has you find the height and do those comparisons and decide. If you want to do it that way, I can totally help you with that. I know how to do it that way too. It's just not the way I choose to do it. I think you will see it is much faster to just check and see if there's a quadrant 2 option. Okay, so I'm going to show you, we're going to do a variety of problems today where we have all those different possible outcomes, and we're going to see where we just check and see if there's a quadrant 2 option, and that's usually the fastest way. When you look on Delta Math tonight, when they show you how to work a problem, they also find the angle with sine inverse, and then they just check for a quadrant 2 option, for an obtuse option from quadrant 2. Okay, So I'm going to do it that way as well. But if you want to do it the other way, I can help you with that. There's always more than one way to work a problem. All right. So let's draw our little triangle. I think it's good to visually have a representation to organize our information. I'm going to call it triangle ABC. Okay, we're given that angle B is 35 degrees. Side B opposite of that is 6 units. Side C, which is opposite angle C, is 8 units. Okay, so look at my triangle. What information do I have? I have a side, the very next side, and the very next angle. So this is a side-side angle triangle, which means there's a possibility of 2 triangles, one from quadrant 1 and one from quadrant 2. There's just a possibility. Okay, so when I see side-side angle, I'm like, oh, this is my ambiguous case. Now, the other way I remember it, I'm like, don't make a donkey of yourself. Remember, there's 2 options. Okay, so don't make a donkey of yourself. Remember, there's 2 options. Again, donkey, because donkey is the other word for the bad word that SSA is backwards. Okay, so I'm like, don't make a donkey of yourself. Remember, there's 2 options if it's a side-side angle triangle. Okay, I know you just love all these memory tips from Miss Weaver. Okay, all right, so let's set up our law of sines and let's start solving this triangle. So we've got the sine of 35 is to the side opposite of it, 6. As this 8 is the other side we have, so the angle opposite of 8 is C. So I'm going to say the sine of, usually for angle C, we'll call it gamma. So I'm going to do the sine of gamma. Okay. If you want to put capital C in your thing, you can, but we're going to have capital C's and lowercase c's, and we don't want those to start getting confused. We usually use Greek letters for angles. Okay. All right. So then we're just going to cross multiply and divide. So I cross multiply in the direction that does not have the variable. Gamma is my variable. So I cross multiply in this direction that does not have the variable and divide by the other number. So the sine of gamma. Now, when you do that, when you cross multiply and divide, you're solving for whatever's here. This time it's not just gamma by itself, it's the sine of gamma. So that means the sine of gamma equals 8 sine 35 divided by 6. Okay, but we don't want the sine of gamma. We want gamma itself. So how do we find the angles? Inverse finds angles. So our first option for gamma 1, and I'm going to give myself more room. So I'm sorry, we have a lot of room here, and I know I'll end up needing it. So I'm going to go ahead and put this up higher. Okay, so we're going to have a quadrant 1 option and possibly a quadrant 2 option. Okay. So our first option for gamma, gamma 1, will be sine inverse. If we know the sine but we don't know the angle, inverse finds angle. So it's sine inverse of 8 sine 35 divided by 6. So let's break out those calculators. And what are we going to make sure of when we're using our calculators today? What are we going to check and make sure of? So Valerie, we said that angle C, we usually use the Greek letter gamma to represent it, okay? And you make gamma just so you go down and loop and quickly come up, okay? So it's like a skinny fish on its head. That's gamma, the Greek letter gamma for angle C. If you want to call it something else, you can, but we will use gamma. You'll see it in the notes and you'll see it in your future math classes, okay? So I use gamma because we're looking for the angle opposite of 8, which is at angle C, so I use gamma, okay? So it's just our angle. Yes, and Megan got it. We want to make sure that we're in degree mode. So I'm going to go check my calculator here. Scroll down to see your mode. And I was in radian mode, so I switched it to degrees. By the way, I'm going to switch to my pen when we're using my mouse when I'm using the keyboard. I noticed that if I do my mouse, it doesn't pop up that extra box. So I'm going to do that. Okay, so we're going to go to functions. We're going to do sine inverse this time. Now the parentheses is open here, so we're ready to go. I'm going to do 8 sine 35, close that parentheses, divided by, and keep an eye on what's going on in your calculator over here. Make sure that it looks right. And then I wanted to put that denominator in, and it was divided by 6. I'm going to scroll out of that and close that whole thing. You could see that phantom arm there. It was showing you where it was going to close it if you didn't. You just want to make sure that looks right. Okay, and I'm going to double check again because I was doing a lot of talking. Yes, I'm in degree mode. Okay, and I get 49.886. Is that what you got? Some of you are getting it? Yes. Okay, let's go back and write it in. It's right. I've got my answer key here that I'm checking against, so it's right. So gamma sub 1, and I'm using a subscript of 1 to indicate that this is our quadrant 1 triangle, our first option for our triangle. So gamma 1 is approximately 49.886 degrees. Okay, and so if I want to write that in my triangle, I can write it in there. This is gamma, so that's 49.886 degrees. And once we know 2 angles of a triangle, what's the fastest way to find the third angle?
By subtracting the thing from 180.
Absolutely. Now we're looking for angle A, which I'm going to call alpha, the Greek letter alpha. So my first option and all of my options in this one are my quadrant 1 options. So these are going to be my first option. So alpha 1 would just be 180 minus the 35 that was given, minus the 49.886 that we just found. And remember, I want to see your work on paper that shows me where you got these numbers. So I always want to see your work, okay? So alpha 1 will be approximately, if we do that in our calculators, 180 minus 35 minus 49.886. I get 95.114 degrees, okay? And if I'm boxing as I go, just found that angle, and then we just found this angle. So that's 95.114. Remember this picture we drew was not an accurate picture. It was just a placeholder picture, okay? Obviously, that angle A is not an obtuse angle in the drawing, but it's just a way to organize my information, okay? What we still need is the side opposite of it. We still need to find side A. That is the last thing we're looking for. And so we can just use law of sines again because law of sines is nice and fast. So if I set up a law of sines, I always want to use my original setup there that has the exact answers. So I'm going to do the sine of 35 is to 6. Is to 6. And if I'm looking for side A, I need to use angle A or alpha. So that's going to be the sine of 95.114. Questions about that setup to solve for side A? Now, this is just an easy law of sines like we were doing yesterday where we're solving for a side. We're just going to cross multiply in the direction that does not have the variable, and we're going to divide by the other number. So that's going to give me, and I'm going to call this A sub 1 because we're in our first triangle option. So that gives us A sub 1 is approximately, let's go do that on our calculator, 6 sine 95. Okay, I'm going to X that out. Keyboard 6 sine 95.114 divided by, oops. Now that, did you see why I said oops? Probably not because I have all this on my screen. Let me go uncover it. Oops, wrong direction. 1/3 times the charm. Okay, so when I did divided by this time, because I forgot to close my parentheses first, it was dividing just the 95. So always keep an eye on what's going on over here and make sure that it looks right. So I'm going to back up, and then it gets me there. Now, if I remember to close my parentheses first and divide it, then it'll pop the whole thing up in the numerator where I want it. And we were dividing by sine 35. So sine of 35. Usually I keep my screen up there so that I can see what we're putting in. Okay, and I get 10.419, rounding to 3 decimal places. I get 10.419. Any questions about the calculator there? Or anybody have problems? I see some of you in your Pear Deck already had those correct answers, so good. You were working even faster than me. Okay, so I'm going to go back and write that in, 10.419. So A sub 1 is approximately 10.419. Okay, so no problems. We're just solving for the triangle. We got 10.419. We called that our quadrant 1 option because the first angle we found was in quadrant 1. It was an acute angle. And remember, we said that's all sine inverse can find for you. Because sine inverse is a function, for every input you put into it, it has only one output because it's a function. So even though there's supposed to be a second output, it can't give it to us. So how are we going to find that quadrant 2 triangle if there's supposed to be one? Well, since that's our reference angle, okay, we're going to, for the quadrant 2 option, so my gamma sub 2, my second option for gamma, is going to be 180 minus the reference angle. 180 minus 49.886. Okay, again, the idea was, this was the big idea. You don't have to show this. This is just me explaining again. So sine inverse gave us a quadrant 1 option at 49.886. There is another angle that will have that same sine value. Remember, in quadrant 1, your sine is positive. In quadrant 2, your sine is positive as well. And if it has that same reference angle, 49.886, it's going to have the same trig value. If we came and found what this sine value was, and let's go do that real quickly because I think it'll be nice just to illustrate this to you guys. So if I do 8 sine 35 divided by 6, again, you don't have to do this. I'm just showing you this as part of a teaching moment. 8 sine 35 divided by 6. We get 0.764765. Okay, now I'm going to leave that here, and I'm going to write that down. It's about 0.764. Okay, if we got the decimal approximation, it's approximately 0.764. Now you notice I didn't get the decimal approximation here because I kept it in exact form so that when I did sine inverse, it was more exact. Okay, but we could have put in sine inverse of that. Okay, what I want to show you is that what we just did when we do 180 minus 49.886, our first option.
Why doesn't it say ABC? Why does it always say BBC?
We're going to have different options. Any side angle, we're going to have different ones on the other slides. You're going to get other options. Okay. They could have called it XYZ. They could have called it RST, LMP. These are just variables. That's not a pattern. That's not going to matter. Okay. What is important is that you've got to have an angle in the side opposite of it. So it'll be either side A and angle A, or side Z and angle Z, or side M and angle M. You've got to have an angle on the side opposite of it to do law of sines. Okay. All right. Try to stay with me on my train of thought here, though. So I'll take questions in just a second. So try to stay with me on what my point I'm trying to make here. And I know it's a long kind of thought, okay? We did sine inverse of this expression right here. We did sine inverse of 8 sine 35 over 6, and we got 49.886. It gave us a quadrant 1 answer, okay? If we do 180 minus that angle, if from 180 we go backwards that much, 180 minus 49.886, I get 130.114 as my second option for gamma, is my gamma 2 option. So this angle here would be 130.114. Okay, now we're going to have a teeny bit of round off error here, but if we go to our calculator and we do the sine of that number, the sine of 130.114, what do you see, guys? It has the same sine value because values with the same reference angles with the same reference angle have the same trig values. The sine at 130.114 is the same as, and I'm going to type it in for you one more time so you can see it. It's the same as the sine of our first answer, which was 49.886. Oh, wait. Oh, I've got too much. I've got it all on the same line. Sorry, I didn't realize I didn't go to a new line. Let me go to a new line. Dun, dun. Here we go. Is the same as the sine of 49.886. Okay. So you see, the sine of that angle is that. And both of these angles have that same sine value. That's why it was an ambiguous case. We didn't know which one was it supposed to be. Was it supposed to be 49.886 or was it supposed to be 130.114? Side angle is not enough information to lock in one triangle. You've got two options that it can be. Questions for me about that? Hopefully that helped you see. Hopefully that helped make a few connections there. Let's jump back to our slide here. Okay, so our quadrant 2 option is 130.114. If you want to draw a second triangle here and start dropping your information in it, you can. I usually find that I don't have to draw a second triangle. I can just look at everything that we found for the quadrant 1 option, and I just know I have to find those same things for the quadrant 2 option, okay? But you can draw a quadrant 2 triangle and start filling it in if you want to. Okay, so we need to now look for our, I'm trying to pick a new color. Well, we need to look for our alpha sub 2 option. So in this new triangle, I'm going to go ahead and draw it because it's our first one, but I probably won't draw it after this first one. Okay, so if we had A, B, C, we were given that B was 35 degrees and that side B was 6. We were given that side C was 8. And we just found that gamma, which is our angle at vertex C, is 130.114. Okay. And so if we want alpha, the fastest way to find it, if we know two angles of a triangle, the fastest way to find the third angle is subtract it from 180. Okay. So 180 minus the 35 that was given minus the 130.114 that we just found gives us our second option for alpha, which is 14.886. Is that what you got? $14.886. Now, if you really want to use the capital letters, remember the geometry notation, because I see a couple of you doing it, would be the measure of angle A is how you have to write that. It's the measure of angle A. And that's why we like just using gamma and alpha and beta, because they represent it, and it's faster to just write alpha than it is to write the measure of angle A, okay? So if you want to use the capital letters, try to use the correct geometry notation there. Or just learn to use the Greek letters. Don't be afraid of them. You're going to see them later in your math career, and so you just want to start getting used to them, okay? All right, so now we know, but our other angle is 14.886. And the only side we need is the side opposite of it. We're going to do law of sines again to find that. Starting with our same original starting, sine of 35 is to 6. As now I'm looking for side A, so I need the sine of the angle opposite of it. That's alpha that we just found at 14.886. Then I'm going to cross multiply in the direction that does not have the variable and divide by the other number. That gives me, I'm going to call that A sub 2. So A sub 2 will be approximately, I'll give you a second to try it. Try it in your calculator. I want to make sure that you have the calculator skills to do these complicated things on your calculators, that you're getting the same answers that I'm getting. Okay, so let's go do that together on the calculator. That's going to be 6 sine 14.886, 6 sine 14.886. Close that parentheses. Remember, that's what I didn't do last time, and that's what messed my thing up. And then divide it by sine of 35. Sine of 35. Okay, I'll scoot that out of the way so you can see what that should look like. I can close that last parentheses. Oops, delete back. Okay, there, it's closed there. And I get 2.687. Is that what you got? Here it is down here, 0.687. Anybody need help with the calculator or have questions about that? So I got as my last option, 2.687. Okay, so this one did in fact, it was the ambiguous case, and it did in fact have two triangles. And that's what that'll work like, and that's what that'll look like when we have two full triangles. Questions for me on that? Okay, you'll be happy to hear that's going to be our only example today that has the full two options, okay? But I want you to understand how the two options work. Okay, so let's talk about this for a second before we move on to another slide. Okay. When we did sine inverse, we got the quadrant 1 option, which was 49.86. That is our reference angle. To find the quadrant 2 option, we did 180 minus the reference angle. Right now, this is 180 minus the reference angle. That's why we did 180 minus that. That was to get our same angle in quadrant 2 that has that same sine value. Both of those angles, we saw it on the calculator, both of those angles have the same sine value. They both have 0.764 ... as their sine value, okay? All right, then in both triangles, to get the third angle, once we knew the 35 that was given and the first angle that we found in both quadrants, the fastest way to find the third angle was to subtract the 2 that we knew from 180. So that's why we subtracted from 180 the second time. Those are very different reasons to subtract from 180. They give you very different answers. Okay. And then we just did a quick law of sines to find the remaining side once we knew everything else. What questions can I answer? This is as hard as it gets, so I want to make sure you understand this before we run through the other scenarios that can happen. Okay, so we're going to pay attention to what information is given. If we're given a side-side angle, we're going to remember, don't be a donkey. There are two options, and we're going to consider the fact that there might be two options. All right, let's try another problem. Okay, this time, I think that maybe that was Noah that asked earlier. See, this time it's A and A that we have, not B and B. It doesn't have to be B and B. Those are just variables. No big deal. Okay. Sorry, I need to make a note for myself. Okay, so I still like to draw a triangle just to kind of help me organize the information. So we're going to do that real quickly. So angle A is 40 degrees. The side opposite of it is side A, which is 3 units. Side B is opposite angle B, and that's 2 units. So we've been given a side, the very next side, and the very next angle. So that's a side-side angle triangle. So don't be a donkey. Remember, there's two options. You can have a quadrant 1 option or a quadrant 2 option, possibly, okay? All right, so we're going to set up our law of sines and start solving it. We need an angle in the side opposite of it. So we're going to do the sine of 40 is to 3, as 2 is the only other side we have, so we have to be looking for the angle opposite of it, which is beta. So I'm going to use beta here, sine beta, and Greek-letter beta. Okay. When I cross multiply in the direction that does not have the variable and divide by the other number, that tells me that sine beta equals 2 sine 40 divided by 3. Now, that's the sine of beta. You can look at a decimal approximation if you want, but we don't necessarily have to, okay? We're going to come over here and start working on option 1, our quadrant 1 triangle. Okay, so if we want beta 1, our first option will be inverse finds angles. So if we know the sine but we don't know the angle, we'll do sine inverse of 2 sine 40 divided by 3. Inverse finds angles. So our beta 1 option is approximately what? Let's go to our calculators. I'm going to X that stuff out from the other problem. Function sine inverse to sine 40, close the parentheses, divided by 3, scroll out of the fraction, and then close that big parentheses. Okay, and so you want to take a look at that and make sure it looks right. That's why we like to write on paper what we're going to put in our calculator so we know what it should look like. Sine inverse of 2 sine 40 divided by 3. I get 25.374 for my first angle, 25.374. degrees. Okay. All right. So now we know that beta is about 25.374. Once we know 2 angles in a triangle, the fastest way to find the third angle is to subtract it from 180. So gamma 1 will be 180 minus the 40 that was given, minus the 25.374 that we just found. That gives me gamma sub 1 is 114.626 degrees. Don't forget your degree sign, otherwise we'd be in radians. Okay, so that's 114.626. Okay, and then the last thing we need is we need side C that's opposite of it. So I'm just going to do a quick law of sine setup. Let me slow down for a second. Are you guys with me? Do we have questions so far? Okay, so I'm going to use the original setup. The sine 40 is to 3. Okay, it's right here in the triangle. What was given? Sine 40 is to 3. Is to 3. And if I'm looking for C sub 1, our first option for C, I need the angle opposite of that. So that's going to be the sine of 114.626 degrees. Okay, we're going to cross multiply in the direction that does not have the variable and divide by the other number. That gives me C sub 1 is approximately, let's go do that on our calculator. Okay, so I'm going to do 3 sine 114.626, close that parentheses, divide it by sine 40. I can close that parentheses as well. Okay, so take a look at my calculator. 3 sine 114.626, that numerator was the cross multiplying. And then we divided by the other number, which was sine 40. Okay, so the numerator is my cross multiply and then divide. Okay, and I got 4.243 if we're rounding to 3 decimal places. 4.243. Questions on the calculator? I know this is tough stuff we're doing today, guys. So if you've got questions, jump in and ask. Okay, of course you're going to have questions. This is new and hard stuff. Okay, so that's our quadrant 1 triangle. That's our first option, okay? What about our quadrant 2 triangle? What about beta sub 2? Well, remember the first angle we find is our reference angle. It's the quadrant 1 angle, and in quadrant 1, the angle itself is the reference angle. So to get the quadrant 2 angle, okay, if we've got our angle here in quadrant 1, if we want to have those same trig values, it's got to be that same distance from the axis. Sorry, that ended up looking off. Okay, we've got to do 180 minus that reference angle to get to the angle itself. Remember the angle's terminal side here. We'll do 180 minus that reference angle to get there. Okay, so here I'm going to do 180. I don't want to do that color. Sorry. (180 minus 25.374). So I get that beta sub 2 is approximately what? And I get 154.626. And this is where I want you to do some critical thinking. So the reason I cannot make you solve for height and then do all those comparisons is because I want you to do this right here. And then I want you to stop and think critically. Can I have a 154-degree angle in a triangle that already has a 40-degree angle? Can we have a 154-degree angle in a triangle that already has 140? No. So that means there's only one option here. There's only one triangle, and we already found it. Okay? So to me, doing this quick check is much faster than finding the height and then comparing it to the opposite and the n and all that other stuff. And I don't think long-term you're going to remember, wait, if O is less than H, then there's, or is it less than N? And part of it is less than H and greater than N, and like all these different combinations. I don't think long-term you'll remember all those, okay? So that's why I think the easiest way to remember is that sine inverse only finds you the quadrant 1 option. It always only gives you angles between 0 and 90. So you have to do 180 minus it to see if there's a quadrant 2 option that works. So we couldn't have found gamma sub 2 first, because gamma sub 2 we do from subtracting the 2 angles that we know. So we have to get beta sub 2 first here, and then subtract the 2 known angles from 180 to get gamma sub 2. I am going to, Nicholas, I said I'm going to do post the recording for you, because I think that, it'll be good for you guys to be able to go back and look over this, because this is deep thinking. Now, you don't have to remember the whys behind all the deep thinking, okay? You can just remember that it's ambiguous, so you got to check the second option. Now, there's also no stress on this second option. If you just started cruising away and you didn't notice that beta sub 2 wouldn't work, and you just started finding gamma sub 2, no problems. You would realize right now when you went to look for gamma sub 2 that there wasn't a second triangle. When you went to find gamma sub 2, you would have done 180 minus the 40 that was given, minus the 154.626 that we just found, 154.626. And what would you have gotten? You'd got that gamma sub 2 is a negative angle. Can we have a negative angle? Heck no. So as soon as you got a negative angle for gamma 2, you would have been like, dope, there wasn't a second triangle, okay? So no worries if you don't catch it on the beta sub 2, you'll catch it when you find gamma. These two calculations are easy calculations. 180 minus the reference angle, and then 180 minus the 2 known angles. Those are easy calculations to do. And when you get a negative option for your third angle, you know there's not another triangle. Okay? Questions about that? Are you guys with me that this is easier than finding the height and then comparing it to all those different things? I don't know. It's me and Delta Math. That's what we think. So that's why I teach it this way, because I think that's faster and easier. But if you want to do it the other way and you have questions about that, I can help you with that too. I do understand and know that part too. All right, so let's see what else we got in our set of problems for the day. All right, solve the triangle. Let's see what we got. I'm going to draw my little thing to organize my information, ABC. Side A is root 2 units long. Alpha, remember alpha is the one at vertex A, so that's 45 degrees. And side B, which is opposite angle B, is 2 units. Okay, so if I look at the information I have a side, the very next side, and the very next angle. So this is a side-side angle triangle. We're like, don't be a donkey. Remember, there's 2 options. Or there may be. We have to at least remember to check for the possibility of 2 options, okay? All right, so we're going to do our law of sine setup. So the angle on the side opposite of it that we know the sine of 45 is to root 2, as the only other side we have is 2, And that's opposite angle B, so I'm going to do sine beta. Now, this one, when we cross multiply and divide, we get that the sine of beta, oof, that was ugly. The sine of beta equals 2 sine 45 divided by root 2. Now, we know the sine of 45 because we've been using the unit circle. Anytime the angle's on the unit circle, I want you to do it by hand. I want you to practice using your unit circle knowledge so you don't forget it, and because this way we'll get an exact answer, and I'll show you in a second that the calculator gives you round-off error, which causes a problem here. So we're going to do it by hand when it's from the unit circle. So can you guys tell me what the sine of 45 is? What's the sine of 45? What's the y value at 45? Remember, Ms. Weaver says she loves the 45-degree angles because the coordinates are easy. They're both the same, so you don't have to worry about which one's which. What are both our x and y coordinates at 45? You got it. Square root of 2 over 2. So I'm going to plug that in for sine 45. That's root 2 over 2. And then I just want to simplify this algebraically. Okay, so in the numerator, I can turn that 2 into a fraction by putting it over 1. The 2 over 2 cancels, okay? And that gives me square root of 2 in the numerator, because if it's over 1, I don't have to write it, and square root of 2 in the denominator. Everybody okay with that algebra there? Questions on that algebra? Okay, what is root 2 over 2 and root 2 over 2 simplify to?
1.
1. It simplifies to 1. Okay, so the sine of beta is 1. The sine of beta is 1. So let's go find our triangle. Okay, so our first option for beta sub 1 is going to be sine inverse of 1. Okay, so let's go to our calculators. Sine inverse of 1. Sine inverse of 1. And what is the sine inverse of 1? 90 degrees. Okay, this is our one right triangle option. Okay. So, sorry. So our first option for beta sub 1 is 90 degrees. Now, I want to show you that if we had not done that by hand in the calculator would have had enough round-off error that we wouldn't have realized this was a right triangle. Let's go put this in our calculator like we did on the others. So we're going to do sine inverse of 2 sine 45 over root 2. Okay, so we're going to put this expression. We're going to put this in the calculator, so sine inverse of that, okay, and see what we get. So if we do sine inverse of 2 sine 45, close the parentheses, divided by square root button is down here, square root of 2, scroll out of the square root and then close that parentheses, and then scroll out of the fraction and close that parentheses. Okay, take a look. I'll move my writing out of the way. That's what it should look like. Or I put an extra, I can delete that one. I thought it would have opened one. On the TI Inspire, it doesn't open parentheses for you when you do a square root, so I automatically closed that, but I can take it off. Okay, it did not give us 90 degrees. Do you see that round-off error? Because it's working with decimals when it found the sine of 45 and then plugging it in here. And so it got us really close to 90, but it didn't know that it actually is 90. So that's where not doing it exactly, you could be off on your angle there, okay? So this one is in fact a right angle. When we did it by hand, we got the exact answer as opposed to that round-off error. Sorry guys, I keep flipping this screen. Okay, so it is actually 90 degrees and not 89.9999999. Okay, so if it's from the unit circle, try doing it by hand. We really won't do that to you again. I just wanted to show it here on the right angle, okay? All right, so then we still need, so we know that that is in fact a right angle. That's 90 degrees. So what does that mean my third angle has to be? Can you see it from the picture? Gamma 1 has to be 45. That's a 45, 45, 90 triangle. That's one of our special right triangles. back from our geometry days. So can you tell me, without even doing a law of sines setup, what is side C going to be? Does anybody remember what a 45, 45, 90 triangle looks like? Remember, if the angles, base angles are congruent, then the sides opposite of them are also congruent. So it will also be square root of 2. So that turned out to be an easy peasy triangle once we found our other angle. Questions for me about that? All right, so we found it was 90. If we aren't memorizing all of that about, oh, there's just one right triangle, then how do I know there's only one triangle when it turns out to be a right triangle? Well, come look at what happens when you do 180 minus the reference angle. If you started to look for the quadrant 2 option, you would do, remember that first angle you find, the sine inverse only gives you the quadrant 1 angle, which is the reference angle. When you do 180 minus 90, what do you get? You get 90. You start finding the same triangle. It's going to generate the same triangle. It's the same triangle because there's only one triangle. Okay, if you did 180 minus 90 minus 45, you would get 45. If you did the law of sines, you would get the root 2. Okay, there's only one triangle when it's a right triangle, and you know that because when you do 180 minus the reference angle, you get the same triangle again. You don't get a different option. You don't get a quadrant 2 option. Okay, it's the quadrantal angle. It's right on the line between quadrants, and so that's the only option. Okay, all right, let's see what else we got. Questions for me before I move on from that one? I told you only that first one was going to be all the full work. We don't have time for our brain break today. I did put a brain break in there, but we're running out of time because Ms. Weaver took a long time explaining. I want to do one more problem with you before I turn you loose. So I did a lot of talking today. So let's try one more triangle, and this one will be fast. Let's find triangle ABC. I'm just going to organize my information again. Okay, so gamma, and there it is typed. That's our gamma. That's at vertex C is 50 degrees. Side C, opposite of that, is 1 unit. And side A, which is opposite angle A, is 2 units. So let's look at the information we have. We're given a side, the very next side, and the very next angle. That's a side-side angle triangle. Don't be a donkey. Remember, there's 2 options you have to check for. Okay? All right. So we go set up our law of sines. The sine of 50 is to 1. As if we want 2, then we're looking for alpha. The sine of alpha is to 2. I'm going to cross multiply in the direction that does not have the variable and divide by the other number. That means that the sine of alpha is 2 sine 50. If I'm dividing by 1, do I have to write it? No. Division. Yep, it won't change it. So I'm just going to write it as 2 sine 50. Okay, and we're ready to start our first triangle. So our first option for alpha, alpha 1, will be sine inverse of 2 sine 50. Okay, so let's go to our calculators. X out that other stuff. I'm going to do sine inverse of 2 sine 50. And what do we get? Undefined. Undefined. Don't be frustrated when you get that. Be like, oh, what does that mean? That means we're happy because, oops, wrong one. There is no triangle. There is no triangle at all. Okay, if there's not a quadrant 1, 1, then there can't be a quadrant 2, 1 because we use the quadrant 1 angle, reference angle, to get the quadrant 2 angle. This means there's no triangle at all. Okay, because we got alpha sub 1 yielded undefined, there was no angle. There was no triangle. Now let me tell you why, for those of you that are wondering. Okay, now, so if we actually found 2 sine 50, we would have seen that 2 sine 50 was approximately 1.532. Like the sine of alpha was 1.532. Now, because we taught the units out of order, you don't really understand this yet. But what we're going to learn is that the sine function is an oscillating wave that goes back and forth like this. It's a wave, and its values are always between 1 and -1. So when we got a sine value that was bigger than 1, that cannot be. There is not an angle with a sine value bigger than 1. The sine values are always between -1 and 1. So if your sine value is greater than 1, sine theta is greater than 1, that yields no triangle. Not that you have to find the sine value to compare it, but that's what it means. If the sine value is exactly 1, then there's one right triangle, okay? If the sine value is less than 1, then there's the possibility of 1 or 2 triangles, okay? Both works. Oh, one other thing I wanted to show you. Any questions about this before I jump back and show you something I meant to point out earlier? You're fine, Gavin. You can go back and watch the video later. How can we know real quickly, like on that very first option where all 3 options existed? Okay, so let me jump this back to that one. Okay. On this first one, how could I have, or let's see, no, the second one, sorry, go forward one more. Okay. How could I have known that there was not going to be a second triangle as soon as I found the first? This is just for people that want to remember, okay? You don't have to remember this because you can always just come find it and you'll see that the second option doesn't work. It's going to eliminate itself. You're not going to have to stress about it. But in case you want another way to know, when the first angle you find is less than the angle that's given, there will never be a second option, okay? So if the first angle you find is smaller than the angle that's given, the second triangle won't work. Because how do we get that second option? We do 180 minus this, and because it's smaller than the big angle, that makes the angle too big to make a triangle with it, okay? It can't add together and be less than it. So if that first angle you find is less than 90, and I'll write this on screen, or less than the angle that was given, okay? I don't have a lot of room left to write it, but. So I'm going to put if beta 1 is less than the given angle, then that yields no second triangle. If the first angle you find is less than the given angle, there won't be a second triangle. Okay, but you don't have to memorize that. You can just do 180 minus the reference angle, and then you see we can't have 154 and 40. That can't make a triangle. Okay, any questions for me on today? I think just checking for the second triangle is easier than doing all the height stuff. But like I said, if you want to hang around during our flex time, I can answer more questions about the other one. That's all I have for you today. You guys are ready to go to try your Delta Math Law of Sines Ambiguous case homework? Are there questions I can answer before you take off? Or before you hang around and do your Delta Math so that I can help you, because you may really have questions today while you're working on your Delta Math? Any questions straight off the bat? Alrighty, then you guys are welcome to work on your Delta Math. I'm here and can help if you have questions. I'm going to close by putting up a recap slide. Let's see. Okay, so what are the 2 cases when we can use law of sines? Basically, this is also something you don't have to stress about. In the notes, the video notes, I know he's already been showing you these kind of triangles, we do this, these kind of triangles, we do this. It's true. Anytime you have 2 angles and a side, and 1 side, or side-side angle. Okay, so anytime you have 2 angles and a side, either angle, side, or angle, side, angle, you can do law of sines for the other side, like we did yesterday, no ambiguity, or side-side angle, but side-side angle, we got to remember, is our ambiguous case. But for me, I don't stress. This is another thing. I don't sit there and try to remember this kind of triangle, this approach, this kind of triangle, this approach. Basically, if you have enough information to set up law of sines where there's only one unknown, you're good to go to use law of sines, okay? As long as there's only one unknown in that original setup, you can use law of sines, Okay. And tomorrow we'll do ones where we can't, where there would be two unknowns if we tried a law of sines setup. So then we know, oh, I can't use law of sines. And that's when we'll use law of cosines.